Good afternoon, everybody. We are going to start our second podcast here on section 15.2. And the math buffs in the room, you guys are going to be excited because we're going back to calculating some molar mass and doing a little bit of math and taking a look at molarity and doing some conversions. So 15.2, we're describing the solution composition. So we've been talking about the two parts of a solution. Hopefully you're thinking in your head, yes, I know the two parts. I know that I have to have a solute and a solvent. And so again, we have to remember those two parts in calculating our percent composition. So this is going to be mass percent. And when you're thinking of mass, you should be thinking of grams. And if I'm given moles, I know I can get back to grams by looking at its molar mass. So mass percent is the mass of the solute. So whatever is being dissolved divided by the mass of the solution, solute plus solvent, times 100%. So again, here's another way of looking at it. So we have the grams of solute, whatever is being dissolved. Again, that is part of my solution, so it has to be divided by the grams of solute plus the grams of solvent. And in most cases, that's going to be water. So if I take a look at this sample, excuse me, I can see that I have a solution that is prepared by mixing 5 grams of salt in 100 grams of water. So hopefully you're imagining some sort of beaker where you are measuring out some water, and then you are going to be mixing in some salt, and we'll make that green, and you're going to pour in your 5 grams of salt, and this is going to mix and mix and mix, and you're going to become a homogeneous solution. So you should think about that both parts are added here, and this total is going to be the 5 grams plus the 100 grams of, hello Alex, 100 grams of solution. So as we take a look, we want to find our percent, and the grams of the solute, we want the percent of salt. So salt is going to be 5.00 grams. Remember, we have 3 significant figures there. Divided by the grams of solute, again, is 5.00 grams, plus the grams of the solvent, which is my water, 100 grams of water. Add those together, and that is what I have started with in making my solution, times 100. And if I do my magical calculator math, and I get 4.76% is going to be my solution. So obviously if I had 100%, I wouldn't have a solution. I'd have all of it as salt, but 4.6% is fairly salty. So you guys have this practice problem right here. Make sure you go through that, and if you get an answer of 3.39%, you have done that correctly. So good luck on that one. Now I have another example with cow's milk. So Jacob and Gabriella, you should be the experts in this area if you're listening. So if we take a look here, we have cow's milk typically contains 4.5% mass of lactose. Calculate the mass of lactose present in 175 grams of milk. So the first thing that I need to do is I need to make sure that I am putting my percent, my 4.5%, into a decimal form so I can use it in my calculation. You guys should recognize percent is divided by 100, part of the whole. So I'm just going to move my decimal point over 2 places, so it's 0.05. So I know that my percent is equal to 0.045 is equal to the grams of the solute over the grams of solution. So here I want to calculate my grams of the solute. I want to calculate the lactose that's present in milk. Well, it's already in there, so the 175 grams, this is the tricky part, 75, sorry. This is the tricky part of reading some of these, in that I have to pay attention. Is this already a solution, or is something else already added to this? So this is already the solution, so I just need to cross multiply that, and x is going to equal, let's see, I need 2 significant figures because I have 2 significant figures in my percent. So that's going to equal 7.9 grams of lactose is present in my solution of milk. So just the same exact formula, just another way of looking at it. And you'll have some examples on that on your homework when I give that to you. All right, the second part that hopefully we can change some gears here and take a look at the solution composition in terms of molarity. Now, back in lab, you guys have seen this millions of times. Many of you asked me, what is that capital M for? You've seen on a hydrochloric acid where maybe I wrote down 0.1 with a big M HCl, or maybe it said 1.0 molar HCl. So now we get to finally figure out what that mystery capital M has been all year long. So we have the number of moles of solute dissolved per liter of solution. So our molarity is equal to moles of solute divided by liters of solution. So again, solute dissolved into a solution that has two parts, a solute and a solvent, gives us the units moles per liter, or a large capital M. So let's walk through an example. So it says, calculate the molarity of a solution prepared by dissolving 11.5 grams of sodium hydroxide in enough water to make 1.5 liters of the solution. All right, so if I take a look at my formula, I know that molarity is equal to moles over liters. All right, so if I take a look at this, I have my liters, I'm okay with that, but I do not have moles. I have 11.5 grams. We are experts at this now. I know that I can take grams into moles, divide by the molar mass. So I have sodium, which is 23.0, that's on the periodic chart. I have one oxygen, that's 16.0, and I have one hydrogen, that's 1. This is going to be 40.0 grams per mole. That should be review. All I did is find the molar mass of NaOH. So I'm going to take my 11.5 grams of NaOH, and I'm going to divide that by the molar mass that we just calculated there, and do some calculations, some calculator magic, punch that in. I need 3 sig figs, and I got 0.288 moles of NaOH. Well, all I need to do is go ahead and divide it by the liters. I already have that, which is 1.50. So 1.50 liters. Do punch it in again. I need 3 sig figs, and I get 0.192 is my molarity of the NaOH. So again, this tells you how concentrated it is. When we talk about concentration or dilute, this helps us out in figuring out those solutions. Well, you probably heard the bell there, so I should be getting back to teaching here. Let's see. So if we take a look at the molarity, you guys are going to be using your mole maps. Pay attention to them. You can see that if we have liters of the solution, you can see molarity that's there. Also volume of solution. So you have these things. Again, pay attention to how to go from grams to moles and moles to grams. This should help you out for any questions that you have on your mole map. And let's see. I guess I am going to have to come back and finish this because I have a couple of minutes of what I want to do to show this example problem. Well, let's just go ahead. All right, so standard solution, a solution whose concentration is accurately known. So to make a standard solution, we need to weigh out a sample of solute. You can do that. Go back on the balance, make sure it's 0, put on your solid or whatever you're doing. Transfer to a volumetric flask. I've shown you this in class. And add enough solvent to the mark on the flask. Remember how we talked about these are very, very precise pieces of equipment? And so we're going to be adding our solid, adding our volume all the way up, and when we do that, we have our solute and our solvent, and you should recognize that this is a homogeneous mixture. Homogeneous mixture makes a solution, 2 parts, solute and solvent. So we need to clearly explain how to make 2.5 molar solution of potassium dichromate. All right, potassium dichromate is K2Cr2O7, and when I do my molar mass of this, I can recognize 2 potassium, 2 chromium, 7 oxygen is 294.2 grams per mole. Remember that when we look at this 2.5 molarity, you need to look at that it means 2.5 moles in 1 liter of solution. So these are 2 pieces, they're 2 parts. Remember, this is dissolved into here. So I simply can say that I have 2.5 moles of my potassium dichromate, which makes it easy enough. I multiply by my molar mass that I just calculated, 294.2 grams per mole. Paying attention to my units, I can see that moles cancel out. I'm left with grams. And my answer is 224 grams of potassium dichromate. So how I would make the solution, if you take a look at the picture back behind, I would take my 924 grams, I would weigh that out, put that in the bottom. I would add enough water until I got up to 1 liter of solution. And that's how I would accurately weigh it. We don't want to subtract anything off to figure out how much water we're adding because of the space and the density of the substances that we are using. All right, so here's your practice problem here. And, oh shoot, I gave you the answer for the practice problem. I'm sorry. This is 924 grams. So if you figure that out and you get 924, you've done it correctly. This is what I get for trying to do it too quickly. This, when you multiply this out, you get 735.5 grams of the potassium dichromate. Excuse me for that mistake. So go ahead and see if you can do this practice problem on formalin, 924 grams. If you have any problems with that, we need to discuss this in class. All right, I'm off to 6th hour. You guys have an awesome day, and I will see you soon.